In this lesson, we're going to be using the distributive property. So we're going to see what the distributive property is and then use it in several examples to help us get very familiar and good with it. So the distributive property states for any real number, a, b, and c, so any numbers that we've been working with, if you have a times the quantity b plus c, so b plus c in parentheses and a outside, it could be the a could be on the left or right, that a is going to be multiplied times the b and multiplied times the c, keeping the same sign in between. So that could be a plus or a minus. So it's often used to simplify algebraic expressions. So we're going to go ahead and start off with a few simple examples. So for example 1, it says distribute 4, and we read this 4 times a plus 3b, because 4 is right outside the parentheses, and we know when a number is right outside parentheses, it means multiplication. A nice thing to do with the distributive property is we're going to draw some lines here just to make sure we multiply the 4 times each part. So we have 4a, 4 times a, so that's 4a. We have our plus sign, and then 4 times 3b, and we end with simplifying that, which is 4a plus 4 times 3b is 12b. And that's the simplicity of the distributive property. If you think of the word of distribute that we use in everyday life, you're giving things out to different people usually, and you're distributing them. So we're distributing that 4. That 4 goes with the a, and the 4 goes with the 3b. Example 2 has 3 terms inside the parentheses, but we still distribute in the same way. This negative 2 is going to be distributed to each one of those terms. Now we want to be careful because it is a negative. So we have negative 2 times 3x squared. A minus sign, so minus negative 2 times 4x, and then plus negative 2 times 5. And so now we simplify this. This is negative 2 times 3x, which is 6x squared. A negative, this is minus a negative, so we know that's going to be a positive. And 2 times 4x is 8x. And then we have plus negative 2 times 5, and we know negative 2 times 5 is a negative, so we have minus 10 here. So I wrote this second line in here, this line right here. It's not always necessary because we can do a lot of these multiplications in our head. Just remember that when you do something like negative 2 times negative 4, negative 2 times the negative 4, that's going to be a positive 8x. We're going to be looking at working with terms. So first of all, we need to know what a term is. A term is a constant, a variable raised to a power, or the product or quotient of a constant and one or more such variables. So a term is simply a constant or a variable or a product of those or a quotient. So some examples of terms would be 3, because that's just a constant. So this is an example. Another example might be m to the 5th. That's a term. But we can also multiply things. So we might have 7x or negative 2x squared y. These are all terms because they're a constant, a variable raised to a power, or the product or quotient of those things. Like terms, so they're still talking about terms, so the things we just talked about above, are terms that have the same variable or variables with those variables having the same exponents. So we would say 2x and 4x are like terms. So these are like terms. Or 3xy squared and negative 7xy squared. Those are like terms. Just to show you, here's some non-like terms. So these are not like, and sometimes they get confused as like. If we have 3x cubed and 7x to the fourth, these are not like terms. They both have the same variable x, but variables have to have the same exponent. So be careful to realize that like terms have the same variables and their variables have the same exponents. And then looking at this this part here, terms of an expression are separated by addition and subtraction. So here's a term, here's a term, here's a term. And then they're separated by addition or subtraction. So here we could say we have 3 terms in that expression. And we're going to go ahead in example 3, we're going to look at that expression and simplify it. So to simplify it, we can work with like terms. And if you think of it as kind of like objects, we have 3x's plus 5x's. Well, we can add that. If we have 3x's plus 5x's, that gives us a total of 8x's. So this is going to be 8x. And then the y, we can't do anything with that. We can't, the saying goes, you can't add apples and oranges or compare apples and oranges. So the 4y cannot be combined with that. We can only add like terms, which is really important. You can only add like terms. You can't add unlike terms. In this example 4, we have 7x squared and a negative 4x squared. Those are like terms. The 8x and the 10x, they have x's, but they're not squared. So they're not like terms with the originals, the 7x squared and the 4x squared, but they're like terms together. So we can add those, and this is what I'll do often is I'll underline the like terms and then do a different underline for other like terms just so we see them. So 7x squared minus 4x squared, that's going to be 3x squared. Just as a note, a side note, when adding and subtracting like terms, you do nothing with the exponents. You do not change the exponents. So this is like having 7x squared. So 7 things minus 4 of those same things give us 3 of those same things. Those things don't change at all. And then we have an 8x plus a 10x, which is 18x. And so that's adding like terms. Another definition called the numerical coefficient, or just the coefficient, is the numerical value or the constant with the variables in a term. So looking up above here, eight we would say is a coefficient. Negative 4 is a coefficient because it's the constant that is accompanying the variable. So 3 is with these variables, so 3 is a coefficient, 18 is a coefficient. So down here in this example below, it says, what are the coefficients of the expression? Well, there's 3 terms, so there has to be 3 coefficients. So the first one is simple, that's 3. The second one, it has a 7 here, but what we're going to do is we're going to say this is negative 7 because we can do plus a negative 7, so that's a negative 7. So be careful of negatives. And the last one, there's no coefficient written there. So if there's no coefficient written, it's understood as 1. So that's just 1x squared. And some folks like to put that 1 in there just to remind them that is a 1x squared. So those are the coefficients for those examples. And now what we're going to do is we're going to do several examples of combining like terms or simplifying stuff like this. A lot of these different examples will bring in different aspects that you need to recognize and you need to be careful of. So first of all, identify like terms, and I do that by underlining them or highlighting them differently, and then we can combine those like terms by adding their coefficients. And so when we add or subtract things, we do not change the exponents. So let's go ahead and look at example 5 here. We have an 8x cubed. So 8x cubed coming across, there's another x cubed. Remember, that's a 1x cubed if you want to put the 1 in there. We have a 4x cubed and a 6x cubed. So there's several cubed terms. So let's go ahead and add those coefficients. We have an 8 plus 1 is 9, plus 4 is 13, plus 6 is 19. So we have 19 x cubed. We don't change that exponent. Now we're going to look at other like terms. So here's an x squared, so I'll do a squiggly under that, a negative x squared, and another negative x squared. So remember, that's like a negative 1 and a negative 1. So when we have a negative 1 plus a negative 1, that's a negative 2. So we can put plus negative 2 x squared. Or I prefer to write it 19x cubed plus a negative is just minus, so minus 2x squared. Moving on to the next one, these have x's and y's, so make sure when we look at like terms they have the same variables, but the variables must have the same exponents. So here's a 4x squared y, so we're going to look for other x squared y's. This one, the next one, the 5, does not have an x squared, so that's not like this negative 10, that's a x squared y. And looking across to the 22xy minus 8x plus y, none of those are like terms. So we can go ahead and combine these two like terms. 4x squared y minus 10. So 4 minus 10 is negative 6 x squared y. Now next, let's just put a little point at that one. So we have an xy. So 5xy, 22xy, and that's it because the other ones are just an x and a y. They're separate. So we have 5 plus 22 is 27, and then we keep those same variables, x, y. And there's a negative x. There are no other, negative 8x. There's no other x's, so we just leave that as negative 8x. And there's a y. There's no other y, so we leave it like that. And so that would be simplified. Moving on to the next examples. More variables, so we're going to make sure we be careful with these. So here we have a 4x squared yz. So we're looking for x squared yz. The next term has an x squared y, but no z. The next term is just xy squared, and then the last term has all x, y, and z, but it doesn't have the x squared. So there's no like terms for x squared yz. So we're just going to leave that. The next one has 2x squared y, which looks a lot like this one, but we have to be careful. In the first one, the x is squared, and the second one, the y is squared. So those aren't like terms. And so we just have to leave those as is. And really, this one was already simplified because none of these terms could be added. So our answer really was just this. We could have just we did just rewrite it. All right, example 8, and then some of the following ones, we're going to be using the distributive property and adding these, and then adding like terms. Now, what we usually want to do is we want to simplify what's inside parentheses first. Can't simplify anything in here. Can't simplify anything in here. Can't simplify anything in there. So we're good with that. Now we're going to add like terms. Now, out here is just a 1. So 1 times something is itself. So this is really just a 2x plus 5. Same thing here. This is plus 1 times that. So that's just a plus 3x minus 9. We don't need those parentheses. But we have to be careful this one because this is minus. So that's like a negative 1 times that. So this is very, very important. So make sure you pay attention to this and really get a grasp of this. If you have a negative out here, that negative, or negative 1, I put the 1 in there, gets distributed to both of these. So what happens to numbers that get multiplied by negative 1? Well, they become the opposites. So when you have a negative outside here, just a negative, you can think these two terms in here are going to become opposites. So instead of having a positive x, we're going to have a minus x. instead of having a negative 6, we're going to have the opposite, which is a positive 6. So whenever there's a negative outside the parentheses, everything inside those parentheses gets the opposite sign. Very, very important to understand. Now we're going to look for like terms. Got a 2x, a 3x, and a minus 1x. We can put the 1 there if we want. So 2 plus 3 is 5 minus 1 is 4. So we have 4x. And then we have some constants, 5 minus 9 plus 6. Now I would probably prefer like, okay, 5 plus 6, they're the positives, that's 11, minus 9 is 2. So 4x plus 2 is the simplified form, for example, 8. So really important part of this is when you have a negative outside the parentheses, make sure you distribute it. And then the last two examples, we'll also take this into account somewhat with a negative there. In number 9, we're starting off with the distributive property. So again, I like to draw these arrows. So 3k times k plus 3k times 2. And then here we have to be careful. This is a minus, so we can think of this as plus and negative. So we're doing negative k times k. So we have negative k times k. This is a negative. And negative k times negative 1. Or actually negative 1, or negative, sorry. Negative k times 1. K times k is k squared. So we're going to simplify each of these parts here. So this is 3k squared plus 3k times 2 is 6k plus negative k times k is negative k squared. And then we have minus negative k times 1, which is negative k. And we know if we have minus and negative, that's plus. So we could finish this by writing 3k squared plus 6k minus k squared plus k. Sorry I said finish it, but simplify it more, I should have said. And now we see we have some like terms. We have a 3k squared and a minus k squared. Remember, that's a minus 1k squared. So 3 minus 1 is 2k squared. 6k plus k is 7k. Now I showed a lot of work for that one. I'm going to erase that and actually redo it. So if you can finish off this way looking at it, and then maybe you can put a line underneath and do it this other way. Just because I want to show you once you get a grasp of it, you can make it a little bit simpler. So I'm going to erase this. Now another way to look through this, I'm going to use the distributive property. So start off the same way. So we don't have to write out all those steps. We can think 3k times k is 3k squared plus 3k times 2. 3 times 2 is 6, so we have 6k. Over here, I'm going to think this is a negative k. That's going to be multiplied times these things. So negative k times k is a negative k squared. And then a negative k times a negative 1. A negative times a negative is a positive, and so that's plus k. So that really can simplify things and make it shorter for you. We still have to add our like terms. 3k squared minus k squared is 2k squared. And then 6k plus k is 7k. Coming to our last one, there are a few different grouping symbols. So we're going to use our order of operations. We're going to work our way from the inside out. Now remember, distributive property is multiplication, so we have to make sure we remember that. So coming to this one, I'm going to leave this 7x squared out here for now. I'm going to give myself a little more room just so I don't run out on the end. So we have 7x squared minus everything in here. So let's start working in here. I still see another set of parentheses. And actually I see addition. So I can't do anything inside the parentheses because those aren't like terms. But then out here, this is right outside the parentheses, so that means multiplication. So we know we do multiplication before addition and subtraction. So I have the 3x plus, and this 4y is going to get distributed to both of these. So 4y times 2x, 4 times 2 is 8. And you might put 8yx, but I always put them alphabetically so it's easier to pick out like terms. So I'm going to put y times x is the same as x times y. And then distributing here, 4y times negative 8y is negative 32y squared. We still have minus 4x, close the brackets, plus 5xy. Looking inside our brackets, we still want to simplify in there. We're looking for like terms. I notice that there's a 3x and a negative 4x. So we have 7x squared, still minus. The 3x minus 4x is negative 1x, or just negative x. And the other two terms aren't like, so we'll just leave them as they are. Now, there's nothing else we can do inside the brackets, so let's look outside the brackets. Notice we have this negative out here. This is what I pointed out earlier in example 8. If you have just a negative out here, that's going to change each sign within the parentheses or brackets or grouping symbols. So that negative here is going to make this a plus x, because we're going to do the opposite of this sign. That's a negative, so we're going to make it a positive. This was positive, so we'll change to negative 8xy. This is negative, so we're going to change it to positive 32y squared. And then we have plus 5xy. So we distributed that negative to each of those terms. We no longer need those brackets because we worked with the negative outside the brackets. And now we're going to look for any like terms we might have. We have a 7x squared, but there's no other x squareds. So we have 7x squared. We have an x looking across. We don't have any other just x's, so we have plus x. We have negative 8xy. And then we do have a positive 5xy, so we can add those. A negative 8 plus 5 is negative 3xy. And then all we have left is this 32y squared. There's no like terms with that. And so this circled part here is our simplified version for that example. And that's using the distributive property. And then in these last several examples, we use the distributive property to help us simplify algebraic expressions. So we're adding like terms